Silas is currently a postdoc here at Ca' Foscari, University of Venice, and he has been looking at South Carolina and Virginia. So we go up now. So.
Okay, thank you. And we're supposed to go at 15 for the coffee break. Okay. All right. So, hello everyone. I'm Silas Dean, and first of all, I'd like to thank our team at Warm Coast, Ca' Foscari. That's Mubashir, Chiro, Danavin, Nikos, and of course, Alessio. But I must also thank our co-authors outside that are helping me with these two projects in South Carolina and Florida. So that's Jackie Osterman. She's been very active helping me understand the GIA models. Dominic Brill, who has been doing the dating and interpretation of the raw dates material. Robert K. Poirier from USGS, who is very active in the chronostratigraphy of the East Coast. And William R. Dorr III from South Carolina Department of Natural Resources, who is like a human XRF machine and knows everything about the local features. And from Virginia Institute of Marine Science, VIMS, Christopher J. Hine, who is helping out with the Virginia material, and his PhD student, Kayla Cahoon, who is an expert on stage 3 and also on the local stratigraphy of Delmarva. So I'm going to start with South Carolina, and possibly we won't even have time for Virginia, but let's see. So the goals and purposes of both these surveys really are, of course, to collect more field data to complement what's already in the Wallace database, and use this data to investigate the patterns of sea level fluctuations during the last interglacial and some of the other stages as well. And compare these with the GIA models in the way that has been talked about all day so far. And maybe make some inferences about global mean sea level as well. So yeah, these two sites are South Carolina, the Myrtle Beach coastal sector, the Cape Fear Arch here, and then up here we have Delmarva Peninsula in Virginia, but it's also in Maryland and Delaware, which is why it's called Delmarva. So let's go with Myrtle Beach. So this is on the trailing edge margin. This is the whole East Coast, also of South America. So it makes it a good place to look for sea level indicators. And we're in the glacial forebulge here, so there's GIA effects to deal with, of course. And this is, as you see here with all these lines, these are scarps, they're paleo shorelines, basically going back to the Pliocene in this area. And each high stand makes a beach ridge and some deposits behind it. And then, there's the low stand, and then there's the next high stand that erodes some of it. And so they should all be in a nice row like this. Here in this particular site in Myrtle Beach, they're close together, some of these scarps. And so in practice, it's a little bit more complicated when they're just within a few kilometers of each other. It's not quite as perfect as all that, so you can't tell what is what without some chronological information. But we have the Intercoastal Waterway Canal here, and that provides outcrops for us to look in and get samples without having to use a core. And so there's some other indicators already in the greater area, such as, the beach ridges, scarp toes, and some coral-bearing fascies. So yeah, this time we went in a boat in the Intercoastal Waterway, and we found the outcrops that are more or less already exposed and have already been located by Rob and Will, among others. And we sampled these for OSL, like that, with a plumbing pipe. And then we documented it with the GPS and photography, because for the actual elevations on the wall of the outcrop, we made 3D models with the photogrammetry, and those are the source of the elevations, because they're georeferenced. And this, in the end, produces elevations with an accuracy probably of about 20 centimeters or less. So, the results. Okay, we examined 6 outcrops. We made the orthomosaics from which to derive the elevations of individual units. We took about 40 OSL samples, and we did sedimentological examinations as well. So we have storm deposits, beach deposits, shallow estuarine deposits, aeolian dunes, some peats as well. But mostly I want to focus on here are the outcrops and all the dates, and which, if you have questions on, we can look at the poster tomorrow or Friday for the specifics of those. But I want to focus on the sea level indicator points from the shell hash, which is this high energy, poorly sorted carbonate fragment rich facies, which seems to occur from the lower swash zone down to the breaking depth. You can see there's cross bedding and things like this. So for the lower bounds of the indicative range, we use the breaking depth from an equation in Lorscheid and Rovere 2019. And then we use this new tool from the Rovere et al. 2025 paper to use wave models for the parameters of the breaking depth equation. And we also use the same tool from the 2025 paper for the upper bounds for the swash zone, which is the composite of run-up models. And the 50th percentile is what we used for the upper limit. And these were both also verified against the actual tide and wave data from NOAA. And there's a pretty close correspondence. So that's good. And so here's a schematic of the indicative range for this kind of facies that we encountered. This will also be on the poster. So if you have specific questions about that, we can talk about that at the poster as well. And then, I'm going to try to talk about the GIA modeling, which is an intimidating prospect with so many actual experts in the room. But let's give it a try. So we got Jackie provided us, I think, with the one from Barnett et al., the 576 permutations, which are the upper and lower mantle viscosity, lithosphere thickness, T2 termination 2 timing, and the 6 different models, ice models. And we wanted to compare this with the main existing sea level indicator in this exact area, which is these scarp toe elevations. You remember back in the slide with the maps, I was showing you these sequences of beach ridges. So the point where the high stand of one reaches the inclined part of another, this part here, the scarp toe it's called, that is considered locally as the elevation of the high stand for that phase. So we said, okay, let's try that. And we, however, used a wider indicative range from the 2016 ESR paper, the Marine Terraces paper, the 5E indicators paper from ESR. Okay, and so this model set doesn't include a GMSL for the interglacial, it's 0. So we added ranges for 3 different scenarios, one from Dumitru et al., 2023, this is 1 to 2.7 meters. Then Dyer et al., 1.2 to 5.3 meters. And then the 5 to 10 meter IPCC, which has percolated into all the official documents in the way described this morning. So basically, the scenario with the lowest elevation for sea level, Dumitru, this matched 45 of our models. What I mean is, the sea level calculated by the model, the permutation of the model, matched the scarp toe in all 3 phases, in 7, 5E, and 5C and 5A, in 45 of those 576 permutations. So then the second scenario, 1.2 to 5.3, that matched the scarp to elevations in 7, 5e, and 5c, 5a, 51 of the permutations. So really, they're all concentrated in the low range because this is not adding too much. And then the 5 to 10 meters matched very few of the models, of the scarp to elevations that we had at this area. I made one of those 5-dimensional grid things like in the Dyer appendix, and they tend to have the higher mid or higher lower mantle viscosities, normal T2 speed, and larger to intermediate Laurentide size, which is the opposite, I think, of the Dyer paper. So anyway, talking with Jackie, she said, basically, this might indicate that the model should have some higher values for the lower mantle viscosity. And she thought, yeah, so this probably means that the likelihood of the 5 to 10 meter GMSL scenarios is not as high, at least looking at this evidence. So here, so these are the scarp toe elevations, and these are the models that fit their high stand somewhere in this MIS7, and then we have 5. And then we have 5C and 5A. 5C and 5A at this site are basically at the same elevation. They're almost indistinguishable, so we grouped them together. And our new OSL dates correspond pretty well with the models after their subset for the scarp toe elevations. I would say, in 5E, our points tend to be a little bit before the peak of the models. So, the sea level was maybe peaking here a little bit earlier. And we weren't able to fit them with this idea of a higher 5C and 5A global mean sea level. You can see this model has the 5C and 5A at like -22 to -18. But, as we don't have indicators in these two phases with a higher elevation, we couldn't get it to fit if we add more GMSL to these phases. Let's see. Okay. So, obviously, this is just one site with a few points of data. But, as Andrea said before, the point is to, iteratively add all these studies together and make comparisons with larger data sets and review papers and things like that. But so far, what we have here seems to be pointing towards the lower GMSL scenarios. And in the Holocene, we even have a few dunes, which, like all the other Holocene indicators from around here, are above the GIA models. Okay, so the takeaway here for South Carolina is that we got 16 new OSL dates from MIS7, from 5E, from 5C, and even MIS2. And then we have a few RSL slips, sea level index points. These are not the high stands, As Carla was explaining, it's a point in time and space. The scarps are viewed as high stands here, but our new data is not a high stand, because the sea level can peak after we take this OSL sample. So the slips we have the last interglacial sea level, relative sea level, at 2.5 to 3.8 meters, plus or minus 1.4 meter. And anyway, as I said, all this seems to support a GMSL less than 5 meters during the last interglacial. So now, okay. Okay, I'll do it quick. So now my next project is Virginia, Delmarva Peninsula, where we have this peninsula that is getting deposited by spits. There's a drainage at different phases from the Chesapeake, and then at each high stand, the drainage gets blocked by a spit prograding southward, and then the next high stand, there's another spit, and so on. So there's this series of paleo channels that goes through the peninsula. And so what we're trying to do is get, in addition to a few new sea level points from these stages, 5E and other stages, we are helping to refine this local stratigraphy, which is in need of updating since the 90s, probably. And so this time they're underground, so we're using a geoprobe. We got some samples for IRSL. We also did GPR. And we have some preliminary results from these 3 cores. At this site, there was a lot of ticks, really a lot of ticks. So this will be finalized this summer. This is my summer activity. And we hope to share more concrete results about this soon. So thank you. This is my end of my presentation. The project is ending, as has been mentioned, so if you hear of any jobs, let me know. So if you have any questions about the project or tick-borne illnesses, please, let's go.